We've got some survey results here. And what these are showing is of a sample of 384 people, um, they were asked two questions. What's their age and what's the highest level of education they've achieved? All right, and this table breaks down the results. You've got the education level in the columns and the ages in the rows. So for example, how many people have high school as their highest level of education and were under 21? That would be 120. Okay, so my question here is, how many ways are there to pick someone whose highest level of education is high school or undergraduate college? So I'm making uh, one choice here, right? I'm picking one person, and I have two groups of people that I can pick them from. I can pick them from this group, or I can pick them from this group. So this is really a classic addition rule situation. How many different ways can I do this? Well, I'll add up the sizes of the individual subgroups, and that gives me a total of 350 ways to do this. Okay, straightforward application of the addition rule. Now take a look at this one. Right here, I want to know how many ways are there to pick someone whose highest level of education is high school. So that's this group here, or is between 21 and 25. And that's this group here. Right? Again, one choice, two different subgroups I'm looking at. So we could do this. You could try doing this by adding up the sizes of those groups. You could add up 128 and 259, and if you did, you would get the wrong result. And you can confirm this pretty quickly if you just drill down, right? If we drill down and look at the individual numbers, if you add up the high school numbers and you add up the undergraduate numbers, you'll see that you do in fact get a smaller number. So what happened? Well, what happened is that we disregarded one of the premises of the addition rule. Right? One of its premises says that the two subcategories you're looking at have to be disjoint. There can't be any overlap between them. And here, there is overlap, right? That group right there. Okay, so what? I mean, how can we answer this question without necessarily going to the trouble of adding up, those six, all six of those subgroups? Well, let's look at what happens when we try to add the 259 and the 128. The 259 is 120 plus 74 plus 65, right? These are the high schoolers. And then what I did was I added the 74, 42, and 12. These are the people in the 21 to 25 age group. And yeah, you can see right here what the problem is. The people in that overlapping region, they got counted twice. They got counted once in each group. So kind of the simple fix is just to subtract the size of that overlapping category, the high school and 21 to 25 group. That takes out this one here, and now all that's left is 174. So the people in that group only got counted once, which is exactly what we need. All right, so this is I don't necessarily want to call it a fix, but this is how we're going to handle situations that look like addition rule scenarios, right? But where the individual categories aren't disjoint. So I've kind of summarized the rule here, and again, we're kind of falling back on some of the set theory terminology that we've used before. So what we're looking for here is the size of the union. We're looking for the 21 to 25-year-olds combined with the high school graduates. And the way we do this, right, is we add up the sizes of the individual groups. That's the part that matches what the addition rule says. And then we have to make an adjustment, right? And then we subtract out the size of the intersection. Remember, intersection is kind of the fancy set theory term for overlap, right? So this got multiple names. Sometimes it's called the subtraction rule. Sometimes it's called the exclusion rule, right? You'll hear both of them used in textbooks and on websites and whatever that talk about this stuff, right? But this is going to be our general rule for handling things that, again, appear to be additional situations, but where that important premise that the two categories have to be disjoint isn't met. Right. So where are we going to go next? Well, this brings us to the end of the first section of this chapter. So in the next section, we're going to go on and we're going to expand on this, right? We're going to take this idea of the multiplication rule, and we're going to kind of formalize it a little bit into something called a permutation. And then we're going to take that a step forward, again, a step further. We'll say, well, you'll see one of the big assumptions that we've been kind of quietly making in some of these examples is that the order in which we make the choice matters. For example, does it matter if I pick the plane flight first or if I pick the rental car type first? Right. So the kind of the next step in our progression here is going to say, well, what if the order doesn't matter? Right? How is that going to affect the total number of outcomes?